Okay, so in this presentation, I'm going to go over the basics of the electric power grid and then the difference between energy and electricity. And so we'll go over these questions here. You can feel free to press pause and read them. Okay, so you had a video about electricity generation, so some key terms in here. We have power point, the grid, generator, power line, substation, and transformer, all each term more awesome than the next. So the question is, where does our electricity, which is electric energy, come from? And yes, I know it comes from outlets in the walls, but that's not really where it really comes from. So think about where it really comes from. And if you actually trace it back, most of your electricity, most but not all of your electricity is going to come from a power plant, okay? So this is the real quick and dirty way how this works. You have a power plant that produces a whole bunch of electricity, um, mostly through burning either fossil fuels or nuclear fission. Okay, so it generates a bunch of heat that spins a turbine, which spins a generator, which generates electricity. So that was all in the video. You feel free to watch that. Okay, so you have all this electricity that's generated, a whole bunch of it. Okay, it goes through a transformer, okay, which increases the voltage. So then it goes across these high voltage power lines. I'm sure you've all seen structures like these on the road, near the road. Okay, so we have these high voltage power lines, which transports it over very long distances at very high voltages. And then it ends up in a substation. You've probably seen a substation at some point. You know, it's usually it'll have a chain link fence around it usually, and there'll be all these lines will be coming in, and then you'll see like these big metal drums. So what that does, it takes this really high voltage, and the substation converts it into a lower voltage. Okay, so then it's what's called stepping down the voltage, and then the voltage after it's goes down, then it transports that lower voltage electricity across the power lines. I'm sure you've seen these before, and there's actually I'm sure you've seen these little transformer drums on the power poles. Okay, so that actually takes this lower voltage electricity down to even lower voltage. We'll talk about voltage and current and everything later. But then, that drum, okay, so that steps down the voltage to 120 volts, which then goes into, houses. So some businesses use higher voltage and so forth, but for our purposes, we'll think about the electricity you use in your home comes from the transformer drum there. So that's the basic process. Big power plant, high voltage lines, goes to a substation, goes to a lower voltage, comes through the lower voltage power lines, goes through another transformer, that ends up, then it goes to your house. So that's where most of our electricity in the United States comes from. And let me just show you this really quickly. Okay, so here is, bring it over here. So this, pretty cool website. This is from the EPA, and you can see the the legend over here. So the big triangles are large coal, oil power plants are yellow. Um, we have digester gas and a few other things. So anyway, you can actually mouse over these and it'll bring it up. So this is all in the Mid-Atlantic region. If you can't see, this is Pennsylvania, Ohio, West Virginia, Delaware. So if you put your mouse over this, here's a big power plant. So this tells you where it is, how big the generators are, and actually it tells you all the emissions that it had in 2009 with the most recent numbers. So anyway, just to give you an idea, there are a lot of these. These are all big power plants that the ones I just showed you in the slide. So this is just a small sampling of the Mid-Atlantic region. There's probably 100 power plants in there. Okay, so that's the main way that we get our electricity in the U.S. So here is a pie chart of all of our electricity, what's called the electricity fuel mix, which is an important term. The fuel mix is basically the mix of fuels that we use to generate electricity. Okay, so I want you to press pause and see if you can place where each of these sources. So each of these electricity sources is one of these slices. Okay, so see if you can place them. Go ahead, press pause and do that, mentally anyway. All right, so here's our 2014 electricity fuel mix in the U.S. So you can see that coal dominates. So actually, if over 40% is coal, about 20% natural gas, about 20% nuclear, and then these, the biggest renewable slice is this hydroelectric. at 6.35. This is actually wind, which is creeping up in hydro, but you look at solar is less than 1%. Biomass less than 1%, geothermal is not much. So clearly this is dominated by the fossil fuels and nuclear. So if you think about, remember I said that most of our electricity in the United States comes from that sort of big power plant model. So of all these slices, which of these are that very model? If you think about it, it's actually basically everything but wind and solar are really the only ones. Everything else uses that big power plant. So this type of setup, it's well over 90%, 95% or so of all the electricity in the United States comes from this basic model, okay? So that's electricity fuel mix. Now, the energy fuel mix, this is important. Energy fuel mix is all of the energy. Electricity fuel mix is just the electricity portion. So if you think about the slices of the pie of energy, you notice that the coal slice is smaller. So actually, let's look at these side by side. So the energy fuel mix, excuse me, the electricity fuel mix is dominated by coal and natural gas and nuclear. So between those three, you have, over 80% of all the electricity in the US. Whereas energy, this is all the energy, this is just electricity, all the energy, it's actually dominated by petroleum. Think about what that's from, basically transportation more than anything else. So cars, airplanes, boats, so forth. So our electricity comes mostly from coal, and then nuclear and natural gas are fairly far behind. Most of our energy is actually comes from oil. Coal is a big chunk, but it's actually number 3, and it's behind natural gas. So natural gas is used to generate electricity, but it's also used for heating and some other things. Nuclear goes all the way from 20% down to less than 9%, okay? So just keep in mind, try to remember to keep these terms straight. If I say electricity, I'm referring to just the electricity. Energy is not just electricity, it's everything. And a lot of people, they just, because they don't think about it, they're like, oh, energy, we get most of our energy from coal. Well, no, we get most of our electricity from coal. We get most of our energy from oil, okay? So to give you a little side-by-side comparison, and feel free to press pause and check out this chart. But there's a big difference between energy and electricity. So if you would take these pie charts and break them down and compare like the coal percentage, so this is 42% coal as electricity and 18% coal as energy. If you compare them side by side, so here's coal. So of the electricity use, it's 42%. Of the energy use, it's less than 20%. So basically, if you can see that there's a huge difference, petroleum or oil being the really big one, that a lot of our energy comes from oil, but very little of our electricity. So less than a couple of percent come from oil, comes from oil. Okay, so there's a difference between energy and electricity. And if you look at the global fuel mix, okay, so this is the global energy fuel mix. It's a lot of oil, a lot of coal, and a lot of natural gas. Not a lot of nuclear. Okay. And then renewables is about 20% of all of the energy. Again, this is not electricity, this is energy. And just if you want one other way to look at the energy use in the United States, so this is the year from 1776 till 2012, and this is just the amount of energy. So you can feel free to kind of check out this chart, but you can see again it's dominated by oil, natural gas, and coal, with nuclear kind of further behind. Okay, so that's it for this lecture.